Hello everyone. In this video, I'll be programming heap insert operation in C++. In my previous video, I've already explained about insert operation. Now, in heap implementation video, I have done the coding of left child, right child and parent, and using array I have created an heap. Okay. So we will be observing like how an insert operation works. So I'll be taking an example. So suppose this is a min heap 1, 2, 3, 4 and 5. Okay. So this is a min heap. So if I draw this as an array form, in index 0 the value will be 1. This is 0, this is 1, 2, 3, 4. So these are the index 1, 2, 3 and 4. Okay. So the value at index 1 is 2, then 3, then 4, then 5. Okay. Now, in case of insert operation, if I see the code, like first we need to increase the size. So the size was 5. Now the size will be 6. So a size is increased. And then we need to add the value which we are passing as a parameter. So we want value 0 to be inserted in this min heap. Okay, so already I have discussed in my previous video that whichever values we are going to insert in min heap, we will be putting that value in the end of the heap. Okay, so we'll be putting it at the end of the array as well as like at the end of the heap. So this is index 5. Okay, so we have increased the size and we are going to put this value at the end of the heap or at the end of the array. Now we need to compare this value with the parent value. Okay, so in order to compare this value with the parent value, like what we can do is that as we are dealing with array, so we will be calling for parent I. Okay, we will be calling for parent I. So first of all we need to find like what will be the parent index of this 0. So if we see in the array, the value of I is 5. So the parent index of this index 5 is, the formula is this. So it's 5 minus 1 by 2, which is 4 by 2, and this one is 2. So the parent index is 3. So if we see in the tree diagram, we find that yes, the parent index is 2 having value 3. And in the array also it's 2 having value 3. So we are going to compare 0 and 3. We are going to compare the values. And if we see, we find that 0 is small as compared to 3. So we are going to swap it. So in this for loop, like we need to iterate from 5 till 0. We need to iterate this complete array, and while iterating there is a condition, like the condition is if the parent value is greater than the child value, then we need to swap it. Why we need to swap it? We need to swap it because we need to restore the min heap property. Right now if we are viewing this tree, we find that it's not following min heap property because 0 is over here. As 0 is the smallest value, so it must be at the top, it must be at the higher position. Okay, so if we check for the condition, we find that the parent value is 3 and it's greater than 0. So if this condition is true, we need to swap the value. Okay, so now 0 will be over here and 3 will be over here. So in the array, in this place 0 will be there and in this place 3 will be there. Okay, 0 will be in this place and 3 will be in this place, and initially our I was pointing to this location. Now we want our I to point to this location. Okay, initially our I was pointing in the newly added values location. Now if the parent value is greater than the child value, then this newly added node value, then we will be swapping those values. So after swapping the value, we need to change the I value. Okay, we need to change the I value. Initially I was pointing at this location, now I'll be pointing at this location, at this location. Okay, now again we need to compare 0, again we need to compare this with the parent. Okay, again we need to compare this with the parent. So now 0 is smaller than 1, so this condition is true, like the parent value is 1 and it's greater than the current value, and the current value is 0. Okay, using the formula also, like we are at this location, so the parent index is I minus 1 by 2, which is 1 by 2.5, and the floor value is 0. So the parent index of this location is this index, 0 index. Therefore we need to compare 1 and 0. So now 0 is smaller than 1, it means that 0 will be over here and 1 will be over here. Okay, the value will be swapped. Now I will change its position from this to the parent's position, to this position. So there will be a condition that if our I reached to 0, if our I reached to the starting cell, it means that we have modified our heap. So this will be the end of the iteration. Okay, so the end of the iteration will be this, like unless and until our I value is not equals to 0, iterate this for loop. But now our I has reached to this location. Okay, so we will stop this and we are going to print the modified array. So the modified array output will be 0 2 1 4 5 3. Okay, so the step 1 was to add it at the end of the array. Step 2 is to compare it with the parent. Using the parent function which I have already made over here, we can easily compare it with the parent's value. So initially the parent value was greater than the newly node value. So if it is the case, then we need to swap it. Our I was pointing to this node. Now after swapping, our I will point to this. Again we need to compare the value of this and this. Okay, so now yes, the parent value is greater than this, so we need to swap the value again. So our I is pointing to this location, now it will point to the root. So if our I reached the root index, then we will stop the loop and we will print the modified array. So the output will be 0 2 1 4 5 3. This will be the new heap which will be created after inserting 0. Okay, so if I run this code, we'll check for the output. So first I need to insert a min heap. So I'll be creating a min heap 1 2 3 4 and 5. Okay, so after inserting 0, the output is 0 2 1 4 5 3. So by this way insert operation works.